Do you want to tell us what is evolution?
Yeah, I think it's very important because this is a word that's used by a lot of people. And if you asked 100 different people what they think evolution is, you'd probably get 100 different answers.
Yeah.
Some people use it to mean a change over a long period of time. Some people use it to mean change within a type or species of animal. Some people use it to mean a change between types of animals. For example, dinosaurs are supposed to have turned into birds. They didn't, but they're supposed to have done. That will be evolution in some people's opinion. So, and in some people, like change over time. Let's take an example. Here is a mobile telephone. The first mobile phone I had, 15 years ago, it was the size of an oil can. It was a huge, great thing. And they have developed. Now, I do not deny that things like mobile telephones get better. That's a form of evolution. But that kind of evolution from type to type to type only happens when you add intelligence. Yeah. People's minds thinking about how to do things. And if you think about the motor car, you think about a motor car in 1900 and a motor car in the year 2000. They're very, very different things. That's application of human thinking, the human brain at work. Now, what evolution that Charles Darwin was talking about, in fact, Charles Darwin very carefully avoided the word. He used the word transmutation of species in his book.
Okay.
Now, transmutation of species means dogs turning into cats, fish turning into birds, cows turning into whales. And that doesn't happen. There is no scientific evidence anywhere for one kind or type of animal turning into another kind or type of animal, or one kind of flower turning into another kind of flower. But if you believe in the theory of evolution, if you really believe it, you have to accept something. Life happened once. And when life happened once, there was a cell. And from that cell, everything is descended. That means that you are personally related to a banana. It means you're related to a cabbage. It means you're related to a Bactrian camel and a bacterium. I mean, you don't need to be a rocket scientist. I may have studied this subject for years and years and years and years. But you don't, the actual things that knock down evolution as a theory are so simple. You see, one of the main rules of science has got a very complicated name. It's called the law of thermodynamics. And I don't want to use terms like laws of thermodynamics, so I have invented my own term. I call it the law of common sense. Yeah. Everything gets old, wears out, breaks down, falls to bits, or dies. Do you know of any exceptions?
I don't know.
No, you don't. I mean, everything breaks down, wears out, falls to bits, or dies. I mean, a fact of life.
Yeah.
Now, bearing in mind that everything wears out and breaks down and dies, how can simple stuff become complicated? Because the law of science says complicated stuff becomes simple. When I die, they put me in a box and I turn back into chemicals.
Yeah.
The chemicals are then used to form, to feed the plant, and the tree grows above me and birds live in the trees and blah, blah, blah. That's recycling, literally. And we're supposed to believe that something simple, like virus, bacterium, a cell, turned into you and me. Now, I don't find the term turned into scientific. That's not science. That's a religion.
Yeah.
Now, this brings us back to a question we were talking about, Darwin.
Yeah.
Darwin studied science in Edinburgh University.
Yeah.
And he failed. He was utterly, totally useless. It's in his autobiography.
Okay.
He failed.
Oh.
As a scientist, he would have made a very good teapot. However, his father wanted him to go to university, so his father suggested he study theology. So he went to Cambridge and he studied theology. Charles Darwin is a qualified theologian, not a scientist. Now, the interesting thing is, very few people have noticed that what Charles Darwin did is he created a new religion, and it's called evolution. Now, for a theologian to create a religion is understandable. But what he talked about was not science. What he observed was adaptation. And I know you... What
is the adaptation?
Well, adaptation is when something changes within a species. Now, or type of animal. I prefer to use the word type because it's easier for us to understand.
Yeah.
I think the man in the street understands what is the bird type, what is the dog type, what is the cat type, what is the horse type, if we just talk about animals for a bit, right? And you look at, there are many different kinds of dogs. I've got a book over there with 150 different kinds of dogs. And they go from Chihuahuas, which are this size, to English bull mastiffs, which are huge things. And they're all dogs. We know they're dogs. But they don't turn into cats and rats and mice and stuff. There is a limitation within breeding. Now, Charles Darwin was a pigeon breeder. He bred pigeons. He was fascinated by them. He spent 20 years of his life doing almost nothing else. And during that time, he realized that there was a limitation to what you can do within the pigeon kind. You can have fat ones, thin ones, short ones, brown ones, yellow ones, white ones, green ones. You can have round ones and possibly even square ones, but they're all pigeons. And there is a limitation. You can breed for pigeons with long wings until you reach a point where there is a maximum wing length, and then it stops. Then the development stops.
Yeah.
You can't turn a pigeon into a dinosaur or whatever it is the theory's favourite theory is this week. It just doesn't work. They're pigeons. Darwin is famous for his finches. Now, this is actually quite an interesting point because they're not finches, they're linnets, but that perhaps we shouldn't point out that his observation was not as good as he thought. But he found in the Galapagos Islands several different kinds of birds, all related. We'll call them finches because they call them Darwin's finches in all the books. And these birds had different shaped and sized beaks. Some of the beaks were long and thin like this pen. And they go into little holes in the wood and they dig out insects and worms and stuff, right? And there were some that had really big beaks like this, like a parrot. And those beaks are good for cracking seeds. Now, on years when it was very dry in the Galapagos, the only seeds that were available, because the plants didn't grow that year, were the seeds from last year which hadn't opened, and they were hard. So the birds with the bigger beaks were able to crack the seeds, and therefore they lived and didn't die, and therefore they had kids who probably had bigger beaks because mummy and daddy did.
That is adaptation.
And that's adaptation.
Yeah.
Because, note carefully, number one, they're all finches. But even if you argue about whether they're finches or linnets, number two, they are most definitely birds. Nobody's saying it turned into a tortoise or a hare. It's a bird. Now, when somebody says to you, this is evidence for evolution, I'm now going to completely throw. I'm going to give you a tool, all of you, a tool to show how you don't get confused what's evolution.
Okay.
And the tool is this: ask people what it was, and then ask what it is. Let's give you an example. Recent discussion about evolution I was watching on television. There were professors with lots and lots of degrees talking about antibiotic-resistant bacteria. And this is a very current fad thing. People talk about it. There are certain illnesses, we've heard about tuberculosis and things, which are resisting the medicine we make. Okay, you don't need to get technical. I can do this, you can do this, you don't need lots of degrees. The question is, what was it? A bacterium. What is it?
Bacteria.
A bacterium.
Yeah.
Where's the evolution?
No evolution.
No, absolutely not. And this is true of so many things. People have said to me, oh yes, but then what about sickle cell anemia? Now, if you go to Africa, there are people who have a disease called sickle cell anemia. Yeah. And if you have sickle cell anemia, you don't get malaria, but you die young. But you may live long enough to have children, and your children won't get malaria. And people say, this is an example of evolution at work. Yeah. Not exactly, because the person who has sickle cell anemia is much more ill than a normal person who can get malaria. And with these antibiotic-resistant bacteria, they are weaker than the normal strain of bacterium. They're just stronger in an environment where there's antibiotics.
Okay.